Dear students, now we are ready to see the problem of identification. Let me start with a definition of what is identification. By identification problem, we mean whether numerical values of the structural parameters can be retrieved from estimated reduced form coefficients. By identification, we mean whether numerical estimates of the parameters of the structural equation can be obtained from estimated reduced form coefficients. If so, we say that a particular equation is identified. If not, it is not identified. We say under-identified or unidentified. An identified equation may be exactly identified or just identified or over-identified. So if the structural parameters of an equation can be retrieved from reduced form coefficients, that equation is identified. Otherwise it is unidentified or under-identified. An identified equation is exactly or just identified or over-identified. An equation is said to be just identified if unique estimates of structural parameters are possible from reduced form coefficients. An equation is exactly identified if unique estimates of structural parameters are possible from reduced form coefficients. That means if you will get only one estimate for a structural parameter from reduced form coefficients. On the other hand, if you will get more than one estimate for some of the structural parameters from reduced form coefficients, it is over-identified. Now, this is the meaning of identification. Remember what is identified, exactly or over, and under-identified. Now, remember this. We say that an equation is identified if it has a unique statistical form. An equation is identified if it has a unique statistical form enabling unique estimation of the parameters. If not identified, that particular equation will not have a unique statistical form. That means there will be other equations similar in appearance to the first equation, so that you may not be able to identify that particular equation. So for identification, what is required is a particular equation must have unique statistical form enabling us to distinguish that equation from other equations. If it has no unique statistical form, it will look alike other equations, so that identification will not be possible. Now let us see the case of under-identification, identification exactly and over with an example. Then we proceed to see the rules of identification. We start with what is known as under-identification. We start with under identification. Under identification. Now, to explain the under identification problem, we start with the demand supply model. Q dt is equal to alpha 0 plus alpha 1 pt plus u1 t. Qst is equal to beta 0 plus beta 1 pt plus u2t, alpha 1 less than 0, beta 1 greater than 0, q dt is equal to qst, the equilibrium condition. Now, this is a structural equation. Due to the reasons specified earlier, we cannot apply OLS to this demand equation or supply equation because the resulting estimators are biased and inconsistent. So we derive the reduced form equations. We use the equilibrium condition, equate supply to demand. U1t is equal to beta 0 plus beta 1 pt plus u2t. Now, we can write it as alpha 1 pt minus beta 1 pt is equal to alpha 1 is beta 0 minus alpha 0 plus u2t minus u1t, u2t minus u1t, so that pt is equal to beta 0 minus alpha 0 by beta 0 minus alpha 0 by alpha 1 minus beta 1 plus u2t minus u1t by alpha 1 minus beta 1. Let this pt is equal to pi 0 plus pt, and as you know, this is pi 0 and this is vt. So pt is equal to pi 0 plus vt. I write it as. Now substituting this pt either in the demand equation or in the supply equation, you will get a qt. And remember this, as we are dealing with a situation in which demand is always equal to supply, there is no need for writing this subscript, demand and supply. You can simply write a qt as a function of pt, qt as a function of pt. You need not write. That means you can consider this as a system of two equations in two endogenous variables. Or you can treat it as a system in which three endogenous variables in three equations, qd, qs and p. And the distinction will be discussed later. And as I told you earlier, in a simultaneous equation system, there is one equation for each endogenous variable. But if you consider this structural equation, there is no equation for pt. But we know that pt and qt are endogenous. This should be remembered. Then, substituting this either in the demand equation or supply equation, let me substitute it in the demand equation. qdt is equal to alpha 0 plus alpha 1. As I told you, you can substitute this. You can do all the substitutions, taking LCM and the like, or you can substitute this. I prefer this because it is easy, and I suggest that you always substitute this into the demand equation and the supply equation. You do all the calculations because it will improve your mathematical skills. So pi 0 plus Vt plus u1t. That will give us the equilibrium quantity as alpha 0 plus alpha 1 pi 0 plus alpha 1 Vt plus u1t. And I call this Qt as equal to pi 1 plus Wt. This is pi 1 and this is Wt. For this simple example only, this pi 1 or pi 1 is equal to alpha 1 beta 0 minus alpha 0 beta 1 pi alpha 1 minus beta 1. This is pi 1. And what is Wt? Is equal to alpha 1 u2t minus beta 1 u1t by alpha 1 minus beta 1. That is Wt. I suggest that you do all these substitutions. You will get a pi 1 and Wt. And as you know, pi 1 and pi 0 are non-linear combinations of structural parameters alpha 0, alpha 1, beta 0, beta 1, as we have stated earlier. Now, if you substitute this Pt in the supply equation, you will get a Qst as equal to beta 0 plus beta 1 pi 0 plus Vt plus u2t, and this is equal to beta 0 plus beta 1 pi 0 plus beta 1 Vt plus u2t. Again, if you do all the substitutions, substituting Pt in this form, and if you do all the substitutions, you will get this as pi 1 again, this as Wt again. That means you can substitute equilibrium price either in the demand equation or in the supply equation. That will give you equilibrium quantity. So these are the reduced form equations. And as you can see in this example, there are no predetermined variables. There are no predetermined variables. We have only Qt and Pt. And in the reduced form equations, you have two reduced form equations, pi 0 and pi 1. Pi 0 and pi 1. And in this two reduced form equations, we have four structural parameters, beta 0, beta 1, alpha 0, alpha 1, beta 0, beta 1. So we have four structural equations in two reduced form equations. Now there is no unique way to estimate them. The reason is that we have two reduced form coefficients, pi 0, and we know that pi 0 is equal to beta 0 minus alpha 0 by alpha 1 minus beta 1. Pi 1, as I have written, pi 1 is equal to alpha 1 beta 0 minus alpha 1 minus alpha 0 beta 1 divided by alpha 1 minus beta 1. So we have two equations in four unknowns. Two equations in four unknowns. So it is impossible to estimate four unknowns from two equations, because as it is known to you, in a system of equations, unique estimation of unknowns is possible if and only if the number of unknowns is equal to the number of equations. Now we have a total of 4 unknowns and only 2 equations. So from the reduced form equations, you will not be able to obtain either the parameters of the demand equation or the parameters of the supply equation. That means the demand equation is not identified. Supply equation is also not identified. As I told you, by identification problem we mean whether the numerical estimates of the structural parameters can be retrieved from estimated reduced form coefficients. In this case, it is not possible. So we will say that neither the demand equation nor the supply equation is identified. What is meant by this conclusion is this. If you have data on price and quantity only, if you have data on price and quantity only and no other information, there is no guarantee that you are estimating a demand equation or a supply equation, because both equations look alike. Demand equation, quantity is a function of price. Supply equation, again, quantity is a function of price. So both equations look alike. Neither the demand equation nor the supply equation has any unique statistical form. So we will say that neither the demand equation nor the supply equation is identified. This can be specified differently. Suppose that this is price, this is quantity, and suppose that our data is generated by intersection between demand and supply curves. Suppose one point is this, generated by a supply curve and a demand curve. Another point, a supply curve and a demand curve. Another, a supply curve and a demand curve. Another, a supply curve and a demand curve. Or you simply consider a single point, price, quantity. Now, this may be generated by this demand and supply curve, or this demand and this supply curve, or this demand and this supply curve. And we do not know which demand and supply curve generated this point. The point is, we have a set of equilibrium points. These equilibrium points might have been generated by any number of demand and supply curves, or these sets may be generated by shifting demand and supply curves. So we cannot estimate or we cannot identify either the demand equation or the supply equation. Either the demand equation or the supply equation. Now you may have a doubt. Suppose that we estimate quantity as a function of price, and suppose that the coefficient of price is negative. Then can we say that it is a demand equation? Or coefficient is positive, then can we say that it is a supply equation? Again, the answer is no. The reason is, suppose that the points are like this. Points are like this. These points might have been generated by this demand curve and supply curve, this and this like this. Even though it looks like a demand curve, it is not generated by the demand curve. It is generated by shifting demand and supply curves. So neither the demand curve nor the supply curve is identified. Similarly, if the points are like this, again these points will be generated by shifting demand and supply curves like this. Again, so by looking on the sign of the coefficient of PT, we cannot say that we are estimating a demand curve or a supply curve. So the point is, If you have time series data on price and quantity only and no other information, then you cannot identify either the demand equation or the supply equation. Stated differently, you cannot retrieve structural parameters of the demand equation or supply equation from the estimated reduced form coefficients. So what is required? We require additional information. Now suppose that demand curve shifts due to additional factor. We know that in the demand function, all the factors other than price are shift factors like income of the consumer, prices of substitutes and complements, etc. So if you specify demand as a function of PT and income of the consumer or wealth of the consumer, whatever it is, then the demand curve shifts over time. The demand curve shifts from D1, D2, D3, D4 like this. When there is an increase in wealth or an increase in income, a change in the prices of substitutes and complements, then we say that the supply curve is identified. So if there is an additional information about the nature of the demand curve, it enables us to identify the supply equation. Similarly, suppose that there is an additional information in the supply function so that the supply function shifts over time like this as S1, S2, S3, etc. This is the demand curve. Then this enables us to identify the demand function. So it is the availability of additional information in the supply function which enables us to identify the demand equation, and that means in the supply equation we introduce an additional variable, say cost of production. This enables us to identify the demand equation. If you introduce an additional variable in the demand equation, it enables us to identify the supply equation. So the point is, if we have information on quantity and price only and no other information, neither the demand equation nor the supply equation is identified. For identification of either the demand equation or the supply equation, additional information is required. That means we have to introduce additional variables. If W is introduced here, it has a unique statistical form. If C is introduced here, it has a unique statistical form. So then demand equation will be distinguishable from supply equation. So demand equation and supply equation will be identified. Otherwise it is not. Now the question is, we regress PT on a constant, QT on a constant. You will get pi 0 and pi 1 because there are no independent variables here. Because in the reduced form equation, all the reduced form equations are functions of predetermined variables. Now only constants are there. No other variable is there. So you may not be able to identify the supply equation or the demand equation. So let me restate the condition for identification like this. For an equation to be identified, that is to estimate its parameters, it must be shown that the given set of data is not produce a structural equation which is similar in appearance to the one which we are interested. So if you want to identify the demand equation, the given data set must not be consistent with another structural equation. That means the structural equation must have a unique statistical form. Then only you can identify it. then only you can identify it. In this case, both equations look alike, and as such, you will not be able to identify either the demand equation or the supply equation. You can estimate pi 0 and pi 1 by regressing P on a constant, Q on a constant, but you cannot retrieve structural parameters, our ultimate interest. This is the case of under-identification. Under-identification. The case of identification, just and over, will be discussed in the subsequent classes.